Hello everyone, welcome to my channel. This is Karuna teaching the course Microprocessors and Microcontrollers. In this video, we are concentrating on flag register of 8086 microprocessor. Flag register is a 16-bit processor. In this register, 16 bits are available. Only 9 are defined out of 16 bits. Those 9 flags act as a status bits: carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, direction flag, and overflow flag. So this register is also known as program status word register. So 9 flags are divided into 2 types: 6 conditional flags, 3 control flags. 6 conditional flags are carry flag, parity flag, auxiliary carry, zero flag, sign flag, overflow flag. Control flags are trap flag, interrupt flag, direction flag. Conditional flags which reflects the condition of the result. These are set or reset by the processor. Control flags control the execution of special functions. These are set or reset by the user. Coming to the conditional flags: sign flag, zero flag, parity flag, carry flag, auxiliary carry flag, overflow flag. Sign flag: after performing any operation, if the result is negative, then this flag will be set to 1, otherwise 0. Okay, so this is set or reset based on the MSB bit of the result. The MSB bit indicates the sign of the data. Okay, so 0 flag: it is set to 1 if the result is 0. It is set to 0 otherwise. Okay, so here if subtraction operation performed between these two numbers, the output is 0, then this flag will set to 1. Okay, like that, 0 flag will set or reset by the processor based on the result. Parity flag: it is set to 1 when the result contains even number of 1s. It is set to 0 otherwise. Okay, for example, if you perform addition operation between these two numbers, the result contains even number of 1s, then this flag will set to 1. Carry flag: it is set to 1 if the result contains carry. It is set to 0 otherwise. Okay, so whenever you perform addition operation or subtraction operation between these two numbers, okay, if the carry is produced in MSB bit position, then carry flag will be set to 1. Next, coming to the auxiliary carry flag: it is set to 1 if there is a carry from the lowest nibble. So here I am taking 8 bits, D0 to D7. Okay, so D3, 4 bits, nothing but 1 nibble. In D3 position, if the carry is present, that carry is shifted to D4 bit position. Okay, then this flag will be set to 1. It is set to 0 otherwise. Okay, coming to the overflow flag: it is set to 1 if overflow occurs, 0 otherwise. When overflow occurs when signed numbers are added or subtracted, the result has exceeded the capacity of the machine, then overflow flag will set to 1. These are all conditional flags which are set or reset based on the result, status of the result given by the processor. Coming to the control flags: these are 3 control flags: interrupt flag, trap flag, direction flag. So interrupt flag is used to allow or avoid the interrupt request coming from external device or from program. If it is set to 1, interrupt can be recognized by the CPU. 0 otherwise. Okay, so this is interrupt flag set or reset with the help of these two instructions: set interrupt flag, clear interrupt flag. Okay, next, trap flag, which is used for single stepping through a program. If trap flag is equal to 1, trap is executed after each instruction. 0 otherwise. This flag will be set or reset with the help of set trap flag or clear trap flag. Okay, direction flag, which is used in string manipulation operations. Direction flag is equal to 1. The registers SIDI, which are used to point the data available in data segment and extra segment, which are decreased automatically when you set D equal to 1. When you reset this flag, these registers are automatically incremented. So likewise, direction flag set or reset by using set direction flag, clear direction flag. Okay, so like that, These control flags are used for controlling the operations which are set or reset by the user with the help of these instructions. Thank you. We will meet in next video.